Hey, fellow mathers! Welcome to the podcast where math is figure-outable. I'm Pam, a former mimicker turned mather.
And I'm Kim Montague, a reasoner who now knows how to share her thinking with others. At Math is Figure-Outable, we are on a mission to improve math teaching.
I said Pam. You said Kim Montague.
I was not listening because I was scrolling to find the intro.
To find what you were supposed to say. I love it. Well done. You made it there. That was good. We know that algorithms are amazing human achievements, but they're not good teaching tools because, y'all, mimicking step-by-step procedures actually traps students into using less sophisticated reasoning than the problems are intended to develop.
In this podcast, we help you teach mathing, building relationships with your students, and grappling with mathematical relationships.
We invite you to join us to make math more figure-outable.
You want to know what I was thinking about while I was scrolling?
I do.
What the question that I asked you right before we got started. So
I don't remember.
I said, "Hey, what math are we gonna do today? What am I gonna be doing?" And you said, "You're going to a cafe." And I was like, "That's not helpful." Okay, I have no idea what we're doing today.
All right, yeah. So Kim's going to be a little bit surprised, maybe.
Talk about vulnerable people.
Bam!
I don't even know what we're doing.
So much fun. Well, pretty soon you're going to do it to me, so that all will be fair.
Okay.
Okay. So a few weeks ago, Nira asked for some stuff with systems of equations, and I know we've taken our time, but I did kind of want to build some things with equations and inequalities. Today, Kim, we are going to dive in and do maybe the coolest thing I've ever seen with systems of equations. And to be clear, I've seen some cool things.
Okay.
I'm totally going to give Cara M a lot of credit. So Cara was my co-author with the Algebra Problem Strings book. I had a super good time writing with her. She is, I think maybe you and I would call her one of the best problem string facilitators.
Oh, yeah. I got to see her in New York.
Wow, it was
brilliant.
I think you saw her twice, maybe.
Couple,
you saw her, and then we saw her together. And when we saw her together, we were like over on the side going, "Oh my gosh!" And we were comparing notes about things that she did and said. Yeah. So thanks, Cara, for that. Okay, so let's dive in to let's go to a cafe.
Okie doke.
So Kim, you go to a cafe and you're buying for the crew.
Okay.
You bought 5 sandwiches and 4 cookies. I don't know who didn't get a cookie. It's not very nice of you, but 5 sandwiches and 4
cookies.
Yeah, 5 sandwiches and 4 cookies.
Need 4 cookies.
Oh, for 5 sandwiches? Somebody eats a lot of.
Oh, I have boys in my house. That's more sandwiches is an option.
Oh, gotcha. Okay, all right. Or maybe it's me and I'm on a diet. That's always the thing. Okay. So 5 sandwiches and 4 cookies, and you looked at the receipt, and those 5 sandwiches and 4 cookies cost $62. Before you get going, listeners, you might want to pause. So Kim, don't say anything quite yet. Could you think of a possible price for the sandwiches and cookies that would get you $62? So don't say anything too fast, but I mean, I guess they can pause. But I'm just going to, just let you brainstorm.
Am I brainstorming?
Yeah. Can you think of a possible? Yeah, I'll let you talk. Yeah.
Okay. Sorry. So if the sandwiches were $10,
okay,
then that would be 50 of my dollars. So then that means the 4 cookies would cost $12, and so they would be $3 each.
Oh, nice.
So it's $10 sandwich and $3 cookie.
Nice. That makes a total lots of sense. Do one more just for grins. What if the sandwiches were like $1?
Oh, I put $2.
Okay, or that.
So if they were really bad $2 sandwiches, then that would be $10.
Okay.
Out of my $62, so then $52 for cookies.
Oof.
Holy cow! So 4 cookies for $52. That'd be $13 for a cookie.
I so want to know how you just did that, but we're not going to go there today.
Okay.
Okay. Cool. Nice. So we could continue to do that, right? We could just in fact, one way that sometimes I'll do with kids, they're like, "No, I don't do numbers." I'll just say, "Well, what if the sandwiches were free?"
Yeah.
Or what if the cookies were free? Yeah, just get them started, kind of thinking about some possibilities. We could brainstorm some possibilities, kind of get a sense for that. And then we could kind of ask ourselves, like, how many possibilities are there? And as we talk about how many possibilities there are, we're going to use technology today to kind of look at all those possibilities. Now, Kim is a self-professed not
techie.
Not
no tech.
Okay.
I'll say that.
So we're just gonna like it'll work. So we're in a Desmos online graphing calculator.
Yep.
Neither of us can see each other, so we're gonna
Okay.
disguise what we're saying.
Ugh.
But Kim, if
Yep.
we were to just type in kind of what we just said, which was 5 times the cost of the sandwiches. So I'm going to put 5x, and x is going to represent the cost of the sandwiches.
Okay.
Plus, because we're going to add it to the cost of the cookies.
Yep.
Plus 4 times y, and we'll let y be the cost of the cookies. Now, Desmos users, we could have put s and c. We could have.
Oh, I was going to ask about that. Okay.
We could have. I don't know why I'm not today. Today I'm not.
It's fine.
And then when we sum those up on the bill, it was $62. Is that right? Yeah. So I just typed equal 62. What do you see, Kim? So 5x plus 4y equals 62.
I see a portion of a line.
Yeah.
Yeah.
So what?
My screen goes from -10 to 10.
And about -9 to 9 or 10. Yeah, about -10 to 10. Yeah. That's the home screen usually.
Yeah. Can I, you gonna let me
I am gonna
find more? Okay.
Yeah. Yep.
Okay, I'm gonna zoom out because I want to see more of the line. And I kind of am interested where they cross the axes.
So you have this gut instinct.
Yeah.
That there's something kind of cool about where they cross the x-axis. Okay. Can you just hover over like where it crosses the x-axis? What is that point?
I have 12.40.
And any idea what that means in this cookie sandwich? Yeah, what does it mean?
If I bought 12.4 cookie sandwiches, I need the S. 12 it would be $12.40 for a sandwich and 0 cost for the cookie.
Hey, there's the free cookie.
Yeah.
There's the free cookie. So listeners, you think about while Kim goes and looks for it, what about the y-intercept? Like where it's 0 and then I'm seeing 15.5. What does that represent in this sandwich cookie scenario?
Well, tell me the numbers you got. I think I lost it. Tech. Oh, here we go. Oh man!
If I pay
$0 for sandwiches, then my cookies are $15.50. That's never happening for me.
Damn, that's never. You would not do that.
$15.50 for a cookie. That's crazy.
I mean, if it was
maybe it's a cookie cake. It's cookie cake.
Ooh,
okay.
A cookie cake. Okay, all right. I was gonna say a really good chips and salsa. You would totally do that.
Oh, for sure.
Yeah. Okay. Cool. So I wonder if we could find one of your. You had said $10 for a sandwich and $3 for a cookie. Can you find that point on that line? Where would that be?
Yeah, but I kind of want I'm just guessing. Why am I guessing? I need to go find it. That's silly.
Can you if you're I'm looking at the line and I literally took my cursor and I'm putting it on the line where x equals 10 and I on the line and it's sure enough it's 10.3. Like there it is. So that's there's one of the ones that you found. We could go find the other one. So we can kind of have this conversation about how there's a lot of possibilities. In fact, if we let this line be, there's sort of an infinite set of possibilities. Now, if we round it off for money, then not so much. But there's a lot of possibilities about what those sandwiches and cookies could cost. Cool. All right, Kim, that was our first problem. Okay. Second problem. What if you went in and this time you bought 4 sandwiches and 5, oh, golly. So on my paper, I have written, well, actually, on the board, I would just have the Desmos graph, 5x plus 4y equals 62. On my paper, I wrote 5s plus 4c equals 62. For the second problem, I wrote 4s plus, did I say 5 cookies?
No.
4 sandwiches plus 5 cookies. And, I mean, we just switched. So it should also be 62, right? Nope. Today it was $55. One less sandwich, one more cookie, and it costs less. Does that tell you anything? I'm just kind of curious.
Say that again. It's one less sandwich and one more cookie. Oh, I wrote 62 again. It's how much? 55?
Sorry, 55, yeah.
One less sandwich and one more cookie, and it's less. So the sandwiches are more expensive.
How do you know that?
Because I have the same amount of things and it costs less. Like when I added one more cookie and had one less sandwich, the price went down $7.
Yeah. So that sandwiches, another way to look at it is to go from the one we just said. If you add a sandwich and take away a cookie, it went up by a lot. So that's kind of interesting. Okay, cool. What do you think that, how do I say this? Could we find some other possibilities for the price of sandwiches and the price of cookies?
Yeah, you mean like on using Desmos? Like you
We
would I mean,
we could.
I could come up with some random ones.
Yeah.
You'd like me to?
Or yes. So I might like look for one. Do you have one? Well, I have a fun one. What if the sandwiches were free?
Okay.
So 4 sandwiches are free. 5 cookies cost $55.
They're $11.
Bam. So there's A, and where would we expect to see that? So let's go ahead and type it now into Desmos. So here's a different.
Do I need my original line? Or
yes, please keep your original one. Thank you. It's a great question.
You're wondering if there I did it. Okay, good for me.
So what'd you type in?
I haven't typed it in yet. I was excited that I found number 2. Clearly, I do not do anything with Desmos.
I love it.
Thank goodness my kids just
they just come home and teach you all the Desmos?
They do. They don't need me for that. Okay.
All
right. New line. Green line.
Yep. Okay. And what did you type in?
4x plus 5y equals 55.
Do you dare try to tell me what that means?
4 sandwiches and 5 cookies is $55.
Okay. And if I could, 4 sandwiches times the price of the sandwiches plus 5 cookies times the price of the cookies is $55. Okay. And so now that I'm assuming it graphed, and what do you see? Can you just describe for everybody what you see?
The line is shallower than the previous line.
Okay.
Like it's less slope.
Can you find that cookie price when we said the sandwiches were free and the cookie was $11? Yeah. Maybe we should have put S and C.
No, it's okay. So I have 0.11. I'm hovering over 0.11. That's 0 cost for sandwiches and 11 for cookies.
Nice. It's and it's there's the intercept right there. And we could go look at the other intercept. It looks like it's not even. I've got 1375 0. So I think that means if the cookies were free, then the sandwiches would cost 1375 each. And then there's all sorts of possibilities in between.
I scrolled out enough, and then there's more to see. I was zoomed in too much still. So the intersect.
Tell me your window now, because I kind of want you to stay in the window that I'm in.
I'm in negative 25 to 30 on that x-axis.
Oh, you moved around. I think that'll still work. Maybe don't move around anymore.
Okay, I was pretty zoomed in.
Okay.
I didn't see that they intersected.
So they do intersect the two. And what's the intersection point?
10.3.
And what do you think that means? That 10.3.
At $10 for the sandwich and $3 for the cookie, I think it's $55. That's $55.
Okay.
But it's also when there's, what does that mean in the other line?
Yeah, what does that mean?
$10 for the sandwiches and $4 for the cookies. No, 5 sandwiches and 4 cookies, and 4 sandwiches and 5 cookies. That's where they are equivalent, or they intersect.
What does it mean that those two? Like one day I went to the cafe and I got 5 sandwiches and 4 cookies, and another day I went to the cafe and I got 4 sandwiches and 5 cookies, and they intersect.
They cost the same.
So you think we're at the same cafe?
No, because one was $62 and one was $55, right?
Yeah, but we bought different stuff.
Oh yeah, we did.
What does the point 10.3 mean? Like that's the only place these two lines intersect, right? And I think you said for the second day we went in, you said, okay, so I bought 4 sandwiches at $10 each and 5 cookies at $3 each, and it costs $55. And you can see that point there is 10.3. But it's also on the other line. If I bought 5 sandwiches at $10 each and 4 cookies at $3 each, it costs $62.
I don't think I understand what you're asking. Oh,
maybe not. Sorry. I'm wondering what that point means for our scenario, and maybe you've already said it. When we did the first line, we had lots of different possibilities.
Sure.
That the sandwiches and cookies can cost. When we did the second line, we had other possibilities that they could cost.
So this point, when I had the first cafe, it was $10 for the sandwiches and $3 for the cookies. And that's that point, 10.3. So in this scenario, it would be the $10 sandwich and the $3 cookie would be $55. Is that what you're asking?
I think so.
That's the price of the sandwiches and cookies on both days.
Yes.
Yes.
Yeah, that's what I was trying to get at.
Oh, sorry. I'm sorry.
So we'll belabor it a little bit.
Didn't I say it was the price?
Probably.
Oh, okay.
Yeah, sorry.
Sorry.
Okay.
It's okay.
So then you go back another day, and this day you bought 6 sandwiches.
6 sandwiches.
And 3 cookies. And today your bill was $69. And I'm curious how do you think you're in the same cafe?
Oh, that's a good question.
And what are you thinking to figure that out?
I think that if the sandwiches were $10, that would be $60. And if the cookies were $3, that would be $9. And so, yes, I'm at the same cafe.
Oh, so you tried it. You're like, let's stick it in there. What would it look like? Nice. What would it look like if you graphed that line that represents 6 sandwiches and 3 cookies costing $69? Predict
you want me
first.
to predict first?
I do, yeah, if you don't mind.
Yeah.
And listeners at home predicting, what might that line look like?
So I think the line where the second day, the line was shallower of a slope. Mm-hmm. This time it's going to be a steeper slope.
Oh, interesting. Well, let's see if it is.
Find the third one. 6x plus 3y
equals
$69.
And? Indeed. Bam. And when you said indeed, it's steeper. Is there anything else that pops out at you?
I don't know the right word, the space between them. It's the steepness is
kind of mirrored.
Yeah.
Okay. All right. There's some symmetry
same change
going
of
on.
Slope.
Same symmetry going on. Okay. Or some symmetry going on. Anything else pop out at you, like where that 0.103 was?
It's at 0. What about it? It's 10.3. Yes.
Do all 3 lines now intersect in 10.3?
Yep.
So we're in the same cafe. You already kind of said that numerically, but we can also kind of there's lots of.
I love sandwiches at this place. Apparently, I go 3 days in a row, but they're the same price, so that's exciting.
So it's interesting that if I just said, Kim, you bought 6 sandwiches and 3 cookies and they cost $69, could you have found lots of different combinations? Yes. But as we look at these different days at the cafe, you're getting different. There's lots of different possibilities for each one of them, but as we graph them, they're all intersecting in the same 10.3, which means the price of the cookies and the sandwiches has not changed.
Right.
Let's do one more. How about 3 sandwiches and 6 cookies? And that costs $48.
Okay.
Cool.
That makes sense.
All right. And why does it make sense? What makes sense to you?
Well, I'm thinking that the sandwiches are $10, so that's 30.
Okay.
And then the cookies are $3, so that's 18.
Sure enough, yeah.
And that's $48.
Cool. And what might that line, if you were to predict that line, what might it look like?
It's going to be the most shallow.
Why do you say that? What is it about the things you've kind of said shallow and steep, but we haven't really talked about why? What about them?
When this price of the sandwich goes down, man, how do I say this? When the price of the number of sandwiches that I buy goes down, it really reduces the total price more than if I were to buy one less cookie.
And that's, sorry, go ahead.
Yeah, I was just gonna say, because the sandwiches are more expensive, when I buy one less of them, my total bill goes down more drastically than if I were to just buy one less cookie at a time.
Yeah. And at some point you said something about a 7.
Did
you remember when that was? Yeah, I wish I would have hung onto it better. But
the change in price is 7 because there's sandwiches are $10 and the cookies are $3, so the change overall is $7.
So, like, if you look between the original price of 62 and the next day's price of 55, there's a 7, and then from that original price of 62 to the third day price of 69, there's a change of 7. So when we went up by a sandwich and down by a cookie, or vice versa, there was this change in 7 that was happening,
right?
Which may or may not tell us the 10 and the 3, but it's kind of interesting that we kind of have that change in 7 going on. Cool. And did you graph 3x plus 6y equals 48, that fourth one?
No, but I'm doing it right now.
Woo!
I'm slow, but I'm there. Okay.
You're doing great. And does it intersect at 3/10? So yep, got the same kind of thing going on. Cool. Yep. So I could continue to keep giving you different sandwich numbers and different cookie numbers, and we could continue to see that because the cost of the sandwiches and the cookies aren't changing, that they are continuing to intersect at that intersection point. We could continue to look at different slopes changing. We could also kind of look for some other patterns in the numbers that I give you. And one of those patterns that I'm just going to sort of mention, because we're going to keep this podcast tight here today, is I could have asked you 8 sandwiches and 10 cookies, 2 sandwiches and 7 cookies, and then I could have asked you for 10 sandwiches. So maybe I'll just repeat the sandwiches in a row. I could have asked you for 8 sandwiches one day, given you the cookies and the cost. Then I could have asked you for 2 sandwiches, given you the cookies and the cost. Then I could have given you 10 sandwiches, given you the cookies and the cost. And a thing that I would have you notice, that I would ask questions about, is that you could actually add that 8 sandwich day and that 2 sandwich day to the 10 sandwich day and notice some relationships happening. You could notice that you can actually add these orders together and the cost of the sandwich and the cookies doesn't change. In other words, you can add the equations of lines together and the intersection point stays the same. And that was a huge stumbling block for me when I was learning systems of equations, because they would say, here are 2 lines that are not the same in any way, but they intersect. Now add them together and you'll get a third line and do stuff with it. And I was like, I'm sorry, what?
Yeah.
You want me to add lines together? And then that you're telling me that has something to do with these first 2 lines? Like, it had made no sense to me that you could add add equations of lines together and that it would maintain the intersection point. You get a whole new line. It's not the same line.
Right.
It's just that, so if you could look at kind of the spider that I have on my Desmos right now, I have lots of different equations of lines. They're all intersecting at that 1, 10, 3, because the price of the sandwich and the cookies didn't change, even if I made sure that I added different orders together and got different final prices. As long as that intersection point, or the price in the sandwich and the cookies, doesn't change, then I have a system of equations that's still equivalent, which means they still have the same intersection point.
Yeah.
How cool is that?
It's super cool.
Woo!
Super cool.
Another thing that we could do if we had more time with this, and that I've done with students in the past, is to kind of keep, at first I kind of messed with the numbers, not very systematically, but I could over time kind of get to where I had 2 sandwiches and 7 cookies, give you the price. Then I could down the sandwich and up the cookies. So 2 sandwiches and 7 cookies. Then I could down it and go 1 sandwich and 8 cookies. And then I could say, well, then let's down it one more time. What about 0 sandwiches and 9 cookies? And bam, you've got the price for cookies, right? Because now you've got the sort of 0 thing happening.
Yep.
And I could have gone the other direction and walked back until I had 0 cookies and just sandwiches equaling that price. And then we could kind of solve for the sandwich price. So y'all, I would suggest, this is a fantastic task to do with students, to have lots of ideas come together and really get kids thinking about systems of equations and making sense of it way before you do anything to have them think about graphing to find the solution, or using elimination, or using substitution. That this is the groundwork for systems, and it's hugely the groundwork for elimination. Bam! All right, y'all, stay tuned, and we'll do more systems of equations coming up soon. Dun, dun. So thanks for tuning in and teaching more and more real math. To find out more about the Math is Figureoutable movement, visit mathisfigureoutable.com and keep spreading the word that math is figureoutable.